Good morning, everyone. Thank you for making the effort to be here this early on the first day of the JEC. Let me see it first. Okay. Before going to the more interesting stuff where you're all here for, I'm first going to present a little bit on the company, allnex. We are a global resins company, headquartered in Frankfurt, and we have a kind of 2.4 billion euro turnover, nicely divided over 3 main regions in the world. The history of the company originates back from Vianova resins, from Hoechst, from UCB Chemicals, and through mergers and acquisitions, we brought us to Huntsman Composites resins, and we developed a quite diversified portfolio of resins on composites. These resins are branded under the name Viapal. You can find them globally, that brand, but also under the brand of Aquaguard, Polyplex, and Ultratech, which are more than focused on Southeast Asia and Australia. Besides a diverse offerings of all types of polyester resins and vinyl ester resins, we have gel coats in markets like sanitary, in markets like pools, marine, and last but not least in transportation. Transportation market will be more or less the focus of this new development, because there is a production of flat panels. Now, allnex in composites, what our vision is to be recognized as a global player in composite resins. In order to do so, our mission is to innovate and to be at the forefront of innovation and create value for our customers and the market. And the focus of our work is on styrene-free, is on gel coats, is on UV curable resins, and is on sustainability. Now, up to now, it was all about allnex. We will start now on the interesting things, likely the subjects that you wanted to hear about this morning. So along with our mission of being at the forefront of innovation, the ambition of the project was to innovate on sustainability, so in the most broad sense of the word, but also on safety on the production floor, on processability, keeping good open time, keeping a nice viscosity of the resin, and as well on durability, surface durability, and also exposure durability. Now, to meet this ambition, we set ourselves some challenges. And of course, these challenges, they ended up in a product profile. The most two important of these challenges we consider to be safety and durability, so meaning that we want to increase the safety in production floor by excluding styrene from our resin, and as well innovate on outdoor durability, so reaching the automotive standard of 3,000 hours xenon exposure. On the process time, there we have chosen to focus on high temperature curing, so setting the standards for flat panel production. The results, the assessment of the results are split into 6 aspects. On the safety aspect, the focus lays on the manipulation and the curing of resins which has consequences for the safety on the production floor. So, meaning that from the resin, we excluded the styrene. Now, of course, excluding the styrene will also have positive impact on the outdoor exposure. Instead, on the resin, we've chosen to go for a fully aliphatic structure. This aliphatic structure combines with aliphatic diluting agents. Diluting agents being methacrylates or acrylates, so not a styrene replacement like vinyl toluene or alike. The result of this change in resin and the result of this change in dilution also ends up in a different labeling of the resin. So we will move away from the exploded chest label, and we will move away from the flammability label. Instead, of course, we talk about chemicals, we add a dead fish label. Talking about the processability. With the processability, we start with the starting point formulation. Starting point formulation, in this case, containing defoamers, containing leveling additives as well as good flow levelings. The formulation was constructed for a knife coating to be applied at a thickness of 200 to 300 micrometer and curing for 4 to 5 minutes at 100 degrees C. An important detail in this case are the choice of the accelerator and of the peroxides. It is important in this case to avoid as much as possible hydrogen peroxide in the chosen peroxide. And the accelerator has also is very much defined for making this product to a good success. And you see on the picture, on the left side, you see a lot of bubbles. On the right side, you see a very nice, smooth mixture of a white gel coat formulation. Looking at the viscosity profile and on the reactivity, it is clear if you look left on the downside, on the left, you see there is a big difference in behavior, in viscosity behavior at room temperature between a standard unsaturated polyester and the new resin that we have developed. This has a positive consequence that the operating window, the window that you can really use the resin, the viscosity stays constant. So there is no steadily increase of the viscosity after mixing all the formulation together. So it remains constant until the reaction starts. At the same time, from the DSC curve, we learn that the resin is highly reactive. Also compared to this to a standard unsaturated polyester. Now this also traces back, this high reactivity, this also traces back to the fact that we needed to choose very, very well, very carefully, the peroxides and the accelerator. This is a setup of our testing, our laboratory testing. So it's the samples were made on glass plates in this case, and they were heated on a heating plate, and the curve is just showing that the heating plate is really getting the surface of the coating at a decent level in a short amount of time. Now, if we look at the curing, this graph relates the curing time to the thickness of the gel coat and to the curing temperature. So what it says is that at low temperature, curing temperature, only there is an impact of the gel coat thickness on the curing time. So you see on the curve, 80 degrees C, curing at 80 degrees C, you need a longer time for low thickness, but then going higher, you end up at short curing time. On the durability of the surface, we first talk about the abrasion resistance. So also the durability of scratches on your surface. It's an important feature, especially for the future maintenance of gel coats. The abrasion resistance of the gel coat was evaluated by abrading wheels, and it seems to be quite excellent. So 5 indicating absolutely no visual effect, and 4 is a very, very slight defect. The evaluations were made with different abrading wheels, and also with the harsh abrading wheels, the results were pretty good. Another aspect of the durability we see in the thermal shock resistance. These panels were exposed to thermal shock from minus 30 degrees C up to 120 degrees C in a setup where the oven is placed on top of the refrigerator. Each temperature 30 minutes, 1,000 cycles, and besides some small, or besides some, maybe not small, besides coloration of the surface, there were no visual cracks could be seen. Assessing the chemical resistance of the coating of the surface. We see that we have split into in-house chemicals and outdoor chemicals. So the in-house chemicals, there are a couple of chemicals which are extremely harsh, like isobetadine. But what we see here is that also the amount of pigment paste is playing a crucial role in getting better results. So the lower the amount of pastes, the better results we see. And if we look at the outdoor chemicals, the effect at any temperature that we tested, going from 45 degrees C up to 75 degrees C, like, what did we test? Sulfuric acid, bird, oh, that's a word I needed to where is it? Bird excrement and so on. There was no effect whatsoever, independing also in this case, independing on the amount of pigment paste. Arriving at the weatherability assessment, together with excluding the styrene from the resin, one of the high focus of this project. In the beginning, a chemical structure was shown to you of an aliphatic structure, and it seems to be it was fully aliphatic structure. It was a urethane structure, having also less ester bonds like all other standards in the market, and also then expecting higher performing in outdoor resistance. The weatherability test was performed, the xenon test, on a 300 micrometer thick gel coat, and is resulting in very good results at 3,000 hours exposure, as well as for delta B value, left, and for the gloss retention on the right. You see there is a very big difference between a standard unsaturated polyester based on isophthalic NPG compared to the new development we are presenting here. Moving into the sustainability. Sustainability, it was one of the first. It was also a challenge. It was also an ambition of us to innovate on that, and it indicates that sustainability aspects can be identified in more than one result of this project. So like no VOC, no styrene, but as well no bisphenol A, like in vinyl ester resins. The production floor will be a safer place by excluding the styrene, and the surface of the gel coat is more durable in all its properties. So if we go and look back to the ambition that we presented before, and compare that with the results. On safety, the choice of the chemicals is resulting in safer workspace. On processability, we have developed a resin with a constant viscosity before the reaction starts, while also having a high reactive system. On durability, the performance of the surface is very robust, including the yellowing and the outdoor and the gloss retention properties. And on sustainability, we discussed the slide before. So in this case, all 4 ambitions were met, and is resulting in our new resin, which we present to you today. It's Raylock GC 4001, of which we believe it is creating a step change in gel coat performance. By this, I would like to thank you for your presence this early in the day, but I also would like to thank the team in allnex who has worked on this project. And I would be happy, if you would have any questions, I would be happy to have them here now or later on our booth, which is in Hall 6E81. Thank you.
Thank you. Thank you. Good morning. And my name is Jim. I came from the R&D from Yoten. So I'm very curious to ask, and it's very happy to see more and more styrene-free resin and gelcoat solution in the market. But how do you foresee this trend to move ahead? By far, I do have the concern because region to region, country to country, the regulation is variable. Styrene is quite sensitive in Europe, but somehow in Asian countries not so sensitive. How do you foresee the trends and the challenge? Thank you.
Well, the challenge will be big. Styrene is a very peculiar monomer and gives a lot of advantages. The trend, we believe that the trend will be towards styrene-free, for sure. Even, of course, you mentioned the European trend. Maybe already in Americas you see also the trend. But in the end, I believe, or we believe, that Asia will also follow. But it will be a challenge, for sure. And there will be a lot of R&D needed to come up with solutions which bring the same properties or similar properties for styrene. Okay, I don't think that there are any questions. Thank you very much. And if you would like to visit our booth, or maybe to talk on other resins than gel coats, please come and visit us at booth 5E81. Thank you.